In this lesson, we're going to review some trig ideas, SOHCAHTOA, cosine law in particular, that will help us examine trigonometry in a new way in this unit. So some reminders from grade 10. Okay, trigonometry involves known ratios between the three sides of a right angle triangle. Okay, we should have three sides. We should be able to name them. Hypotenuse, always across the right angle. The other two sides are in relation to the angle that you're working with. So I want to work with theta down here. Opposite it is across, and adjacent will be beside. Three primary trig ratios. The sine ratio is opposite hypotenuse, cos is adjacent hypotenuse, tan is opposite and adjacent. And hopefully if you remember nothing else from grade 10, you remember the word SOHCAHTOA. SOHCAHTOA. Remember, to use SOHCAHTOA, it's got to be a right angle triangle. Okay, so we'll try a couple. There's only three problems you can really do with SOHCAHTOA, and they all depend on one of the x's. So in the first question, first thing you want to do is label things. Hypotenuse is obvious, it's across from the 90, okay, and across from the given angle, that's our opposite. SOHCAHTOA, we'll write down one more time to remind ourselves. I want to pick the two letters that are labeled, so O and H in this case. So the sine of the angle I use to label equals my opposite over hypotenuse, O then H. To solve these, we cross multiply. 1 times x, x. 36 times sine 72, 36 sine 72. Put it into our calculator and we should get 34.23. If you're operating a backwards calculator, remember to plug yours in, you have to do 72 times 36 sine equals. You always have to put the function in after the number you want to work with. Okay, that's question number 1. And by number 1, I mean that we can put the x on the top of the fraction. If we try the second one, again, we're going to label according to the given angle. So the hypotenuse is obvious. Beside the angle is my adjacent, A and H. Oh, that's a cos question. Cos of my angle equals my A over my H. This is the second type of question with SOHCAHTOA. X is on the bottom. But we approach them the same way. We think of there being a 1, and we cross multiply. 1 times 48, 48. X times cos 40, x cos 40. Unfortunately, this time, x has not been isolated. So to do that, we have to divide out the cos part. So to get x, we're going to divide 48 by cos 40. Again, we'll put that into our calculator, and I ended up with 62.66. Okay, for backwards people, 48 divided by 40 cos equals. Okay, make sure the number before the function. Okay, that's problem 2. X is on the bottom of the fraction. The only other problem we can do is when x is the angle, as we have in example 3 here. So we're going to label first. I got an H, I've got an A, the cos of my angle I used to label equals A over H. To find unknown angles, we use an inverse function. So we're going to take the inverse of whatever 12 divided by 24 happens to be. Now this is a nice one, 0.5, but if it wasn't a nice one, you're going to use brackets and use your dividing sign in your calculator, and it'll do the work for you. I got 60 degrees is my angle. Okay. The only 3 questions we can do with SOHCAHTOA are those 3. Those will be something maybe on a learning goal sheet to remind yourselves of how they work. Okay. Let's use them a little bit. So, some applications we should be familiar with. Okay. Most word problems can be broken down into one of 2 categories. They could be depression or elevation. Elevation references the horizontal line and upwards. So if we were standing looking out a window of a building, there's my building, ground. Okay. If I looked normally out the window, I would have an angle of 0. But if I look upwards, I've elevated my view, my angle of elevation. Depression goes downwards from the horizontal. So again, back to our window idea here. If instead of looking straight out the window, I look down at something on the ground, this would be depression. So elevation, depression. And we should remember those things are related to each other by the Z pattern. A good example of this is, again, You have a friend who's standing on the ground down here. They look up at you and you're up in a window. The angle that they're looking up at you is the same as you're looking down at them. Those two things have to be the same. Okay, so it's about interpreting some language. All right, let's try some examples. The hard part of this is usually the pictures. Math is one of those three problems. It's about drawing those pictures though. So the angle of elevation of the sun is 23. So if we're standing on the ground and we look up at the sun's up here, it's a really bad sun, our angle of elevation is 23 degrees. If a building is 76 meters tall, so I'm going to put a building between us and the sun, 76 meters, and it casts a shadow, shadows appear on the ground, how long would it be? Here's my picture. I'm going to label it, so the adjacent and the opposite. Tells me we're going to use tan, so the tan of 23 equals opposite over adjacent. That's one of my three questions. I can cross multiply, so x tan 23. I don't have x by itself, so I need to divide it out. 76 over tan 23. And x comes out to, I got 179.04. We're going to try and keep two decimals for everything. Okay, I got the basic one. Try a slightly more complicated one. The tip of a fishing rod is 1 meter above the water. The fish finder has identified fish at a depth of 45 meters. How much line is needed to catch the fish if the line's at an angle of 67 to the surface? So let's visualize this. Here's the water. We've got a guy sitting in the boat, and he's got the fishing line 1 meter above the water. That's the tip of the fishing rod. But the line comes out and tries to catch our fish. Fish are down here, right? Fish. That's a really bad fish. Presents a fish. Way below. How far below? Those fish are way down here, 45 meters below the surface. Well, if I finish this, doesn't that kind of look like a triangle? What do I know about that triangle? Well, I know from the tip of the fishing rod all the way down to the bottom is actually 46 meters. Right? The 1 meter above the water plus the 45 below. I also know the angle that the line hits the water is 67 degrees. And based on the fact that this triangle has an F inside of it, this also has to be 67 degrees. And if I want to know how much line do I actually need, that's my X. I now have a situation where I have an opposite across from my given angle, a hypotenuse, and I can solve using the sine. Oh, it's not 76, 67. So the sine 67 equals the opposite, which is 46 altogether, over x. Cross multiply. It kind of looks like the last one now. Divide out. And how much line do we actually need to catch those fish way down below the surface? I get 49.97 meters. Okay. All right, we'll try one more. Just getting warmed up today, okay? So we have Ingrid. She measures the angle of elevation from a point on level ground. Right, so I need level ground, elevation, so I'm looking upwards. To the top of a building. So we need a big building. Okay. Up in that building, elevation 32 degrees. She walks towards the building. She's now here. Until the angle of elevation is 45. Angle of elevation is now 45. And we actually were told the building was 120 meters high, 120 meters. I want to know how far did she walk? Okay, there's my X. What can we do with this? Well, I hope that you guys see this as maybe two triangles. We've got a triangle that's 120 meters. This is 32, and it's X distance. Actually, I won't call it X. That may cause some confusion. Let's call it Y meters from the building. In other words, all the way from the building. That's one of our triangles. we have a second triangle, 120 meter building still. She's closer now. This is 45. Right? And we'll call this Z. Right? Just from here. This is Z. This is Y. If I want to know how far she walked, all I really need to do is figure out the difference between how far she was at the beginning and how far she is at the end. So I can solve these two problems and figure out the difference between them. So the left-hand problem here, opposite and adjacent, that's the tan of 32 equals 120 over y. Oh, I've solved that problem a few times today. Cross multiply, divide, and initially she was 192.02 meters from the building. Okay, well, let's figure out how far she is now. Again, use this one this time, opposite and adjacent. Tan of 45 equals 120 over z. Same problem, just different numbers, right? Z tan 45 is 120. So z is 120 over tan 45. And z is 120. Oh, that's weird. How did that come out to the same number? Well, trick question almost. If this is 45 down here, this also has to be 45. It's actually an isosceles triangle. And if you recognize that, it would have saved you some time. But if you didn't, we can still do the math. Okay, we want to know how far she walked, right? So how far was she from the start? She was 192 meters. Now she's 120 meters from the building. So therefore, she walked 192.04 minus 120, 74.02 meters. Okay, that's reminders of how we can do trigonometry. I'll review stuff today, finding angles, cross multiplying and solving, setting up pictures. We need to be able to do some SOHCAHTOA to allow us to do the next section of trigonometry though.